for whatever reason, this mic's radiating noise. So it's probably a combination of things like the cable shielding coming up here. The mic doesn't have a ground, it's floating. TV's like, okay. I mean, this isn't exactly made to pick up the noise that's coming out. It's an artifact. So today, we're standing by Niagara Falls.
Mm-hmm.
Yeah.
Yep.
And the one thing that the falls has got going for it that's really cool is it generates electricity.
Quite a lot of it.
Yeah.
Quite a bit. It's been doing it for a long time. Like since Nikolai Tesla was around.
That's right. You can see the little plant he had a little part in over there in the background on the Canadian side.
He had his own shop there back in the day in Buffalo.
Yep.
In the falls, but yeah. I think he was experimenting with transmission lines. I don't know what he was doing.
I think the whole thing, generation, transmission.
It was all at the beginning of time, where they were just trying to figure out how to light a light bulb.
Oh, AC,
in a house. Yeah.
Well,
send it out there.
Yeah.
Because isn't he the guy that wanted
wireless power?
But he was going to do DC, right?
No.
He's AC.
Edison was doing DC.
Edison was DC, yeah. So Tesla won out.
Yeah,
there's a whole backstory to that, which you could look up. But the two of them were
They hated each other.
Yeah, pretty much, yeah. Yeah. Which if they were in the same room, they'd probably shoot each other.
Well, they were at one point.
They'd probably have a duel with pistols at 10 paces.
I don't know about that.
They were. That's how it started. He worked for him.
Oh, yeah, there's a whole backstory to that, which people can look up. It's probably interesting, actually. There's
a lot of videos.
Yeah,
there's videos done on it. Anyway, we want to talk about power. And, specifically, I think, there's all kinds of things we could talk about, but any electronics, you name it, any device requires energy to work. There's no such thing as passive electronics. Well, okay, I shouldn't say that. You could have passive electronics, but they don't offer any kind of gain. You don't get amplifiers that run off of air. It's not like an air fern or a plant.
Well, you can actually.
Yeah.
But it runs on
something
from the air.
Yeah.
So
you need to generate power to obviously to power some electronics. Anything that's got a transistor or a tube or any active device. So anyway, that being said, in audio, particularly in the upper end of things or even the mid-level things, power supplies matter. And a lot of times the power supply that runs the device is what separates the mediocre stuff from the real good stuff. You could take the same amplifier circuit, let's say, right, and put two different power supplies on it and have it sound different. And so, we just want to try to cover some of that because there are manufacturers out there that make devices, headphone amplifiers, and so on, that are designed to work with external or optional power supplies. And some companies are really keen on that.
Yeah, so I guess why would you have an external power supply in the first place? It's probably a good place to start.
Like, what's wrong with the one that's already in it?
Why can't you put it in a box?
Yeah.
Well, I mean, the easiest one would probably be just size. You don't want to make the box bigger, right? Just put it out, make another box.
Sometimes you see that in consumer products. They have an external brick you plug into the wall, especially obviously like laptops and stuff like that. A lot of times in things like laptops, it has nothing to do with the performance or whatever. It's just physically easier to put the heat, the size, the weight outside of the laptop. Then it makes your laptop look like it's thinner and lighter. But, you get this brick and you don't carry the brick with you. It's outside. So sometimes it's something like that, just mechanical. But in audio, usually what we see is people take the box outside of the amplifier for noise, radiated emissions, things like that. Sometimes it's just a perception. Sometimes make it look fancier. And it could be a practical reason. It could be you run a tube, power stage, and it's just physically large. It puts off a lot of heat.
You see that a lot when you have electronics that are sensitive to noise. Like, you brought up earlier, well, not in this video, but we talked about phono stages.
Right.
And
they're very sensitive.
They have 50, 60, 70 dB a gain, which is like, I don't know, what is that? A few million times input? It's a lot. It's a ridiculous amount of gain. So you're multiplying the input voltage in microvolts and making it put out volts. So it's a millionth of a volt in, volts out.
Right.
That's a lot of gain. So it's very sensitive to noise, especially power supplies related. And I mean, the guys that design these circuits, and mic amplifiers are like that too. Like these microphones.
Right.
I mean, we're running 20 dB gain out of it down there, and then we're going to a mic pre that has up to 60 or 70, which is adjustable. So, there's a lot of gain here. So anything that these cables or the mic picks up can be amplified and heard. So it's a project to design really good circuitry that's so quiet that it doesn't get into the circuitry, and the power supply is a huge part of it.
That's why people so commonly have issues with mics and audio and noise, cell phones and things like that,
Big
causing
time.
noises, because they are incredibly low output devices. They're very, very sensitive to all the noise surrounding us. And of course, that's variable, and that's part of the issue. So sometimes the reason why people remove power supplies from units is just to get the noise away, because it's
Isolation.
easier
Yeah,
physically.
Right. That's the easiest way to do it.
Right.
'Cause
Cheapest.
if you put the power supply in the box with the electronics, now that whatever that power supply is radiating as noise can couple right into the electronics. So,
Right.
some people put steel or aluminum walls, so to speak, or
Sure.
try to isolate the supply into chassis. The better designs have metal in there to try.
But it costs money,
Well, right. And
and
when
it's
you're
not perfect.
and a lot of times when you're dealing like magnetic fields, that the power transformer, if you're ever running a power transformer and there's actually a field emanating from it, aluminum doesn't stop that. You need steel.
It takes a lot.
And steel is heavy, it's weighty. And then even then, when you put steel, now what does the steel do with the magnetic field once it picks it up? Well, it actually generates eddy currents that flow through the chassis, and the PC boards and stuff can, again,
You gotta deal
induce
with
it.
it.
Yeah, so it's not, there's no real, the solutions are infinite, so to speak, and they're also complex. So the easy solution is to, instead of dealing with all that, is just throw the thing outside the box.
Right, it can make
put
noise
it
out
somewhere.
there.
That's
right.
Yeah, right. Let it do what it does
That's
out
right.
there, which may be a bitch for something else in the room,
Could be.
but it ain't a problem for that piece.
Right.
So that's one reason is isolation, physical isolation.
Yeah, I ran into that where my turntable had an external power supply for the motor in it, and I had it kind of near the my phono stage, and it just picked that. I just
right.
So I was like,
Kind of like a
it was
buzzing
good for
hum.
the turntable, but then
Yeah.
bad for some other things.
The thing I see more often with stuff like that on external power supplies is they kind of feel like they can get away with more sins. So it tends to mean the power supplies might be noisier electrically because they figure, well, it's not going to interfere with my gear, right? So you, to some extent, you almost need to be more cautious if the power supply is external about where it's placed, because if you put it right next to something else, well, it won't interfere with the piece that it's going to, but it could interfere with another thing.
Like cable run, like a lot of people just lay it on the floor, and then
Yeah,
you
stuff's
got some
laying on
interconnect
stuff.
cable running right next to it. So now the cable's picking up the noise. It's still the same problem.
Right.
You're inducing it's an airborne radiated field coming off the supply.
Right, and it'll couple into conductors that'll cause actual voltage potential. It'll cause a signal in that line.
Which is a lot of times why you see power supplies made in metal chassis. Whether they're internal or external, they tend to try to use some sort of metal to at least try to shield it. So anyway,
But it's not perfect.
Not right.
Never.
No shield is perfect, and some stuff gets through, and just depends. I mean, it's a variable. So recommendation in that is try to keep cables away from power supplies. Try to keep cabling away from power cords.
Yeah.
They can cross each other, here and there. That's okay, but
You want to minimize the contact.
yeah, you don't want them to be running next to each other for any length, because they just, one could get into the other one, and that's just the way it is. But there's other reasons too. Like, you could technically make an external power supply bigger by making an external, where, like you said, it wouldn't fit in the box. It's not practical to fit it in the box.
Right.
So let's just throw it in a big box somewhere else, and even if it takes up another shelf on a rack.
Right.
And I've seen preamp companies with preamps do that. Amplifier companies do that. Hell, some of the headphone manufacturers like R11 Audio, the Formula S has an outboard power supply. You could purchase a separate power supply.
Right.
It makes sense, because now you could have an option if you want. You could put a average power supply in the unit and an optional plug for an external one. And maybe you need to fit a certain form factor or a size, and it's just not reasonable to fit all the stuff you want inside this same enclosure. So you can have a separate one that goes outside. So there's practical reasons like that, sure.
Yeah.
But sometimes you do need to deal with it. And occasionally you'll see, like on smartphones is a good example. Everything needs to fit inside the smartphone, right? And you have a lot of stuff doing complicated things. So usually in smartphones, if you look, they have little boxes covering everything. There's little metal shells all over the place, covering all the little
Very
separate
little.
components. Yeah, because they need to be jammed. Everything's touching each other, right?
But
It's
yet they
shoved in
try
this
to
box
isolate the noise.
as best you can.
Yeah, because
And
it's such
not
a small
perfect.
area. right?
Yeah, you physically can't put the processor outside.
Yeah,
of the phone.
right,
If you can't get it far enough away.
Yeah, everything's like a quarter-inch apart.
Yeah.
You
So
just
it's in a
can't do
little
it.
box.
Especially like the antenna for the
Yeah.
Wi-Fi and stuff like that. That's actually radiating a friggin' RF signal,
Yeah.
and it's a high frequency. But that high frequency could get back into its own electronics, and so they call piss on his own bathwater.
Well, you don't
Piss in
want
its
the
own
Bluetooth
bathwater.
interfering with the Wi-Fi and the cellular and the wideband, and there's like 15 different radios.
Yeah, and they're all transmitting and
phones.
receiving all at the same time.
Yeah.
It'll actually masks itself. It could actually interfere with itself while it's transmitting and receiving. So,
Yep.
but yeah, and so it's a RF is a complex.
It's voodoo.
Yeah, it's magic. And I remember years ago. We think about FM radio, which we happen to have a radio sitting here.
A
got a
vintage
demo.
one.
FM radio. When you think about all the things that a radio station has to go through to get a signal from a transmitter 50 miles away on a hilltop somewhere, because they need height for the transmitter in order to have a line of sight. You got to have a line of sight for the signal to get to you. If you have earth in the way, it doesn't go through the
Not
earth.
so
That's
much.
Yeah, it's not good at that at all. So basically, normally up in a hill somewhere is where they put the big transmitter sites with 300, 400, 500, 1,000-foot towers. Old TVs like that too. Anything with,
Same thing.
Yeah,
Cell phone's the same thing.
right. That's
Yeah.
true.
If you're getting a signal, you probably could pretty much see
You got to see
the
it.
tower. Like
Yeah.
it's not a lot in the way.
It's a
Otherwise
much
you get
lower,
garbage signal.
way lower powered device.
Well,
but
that's
right,
the other reason,
that's why there's so many of them.
They're
Like
everywhere.
you could drive a half mile and see a cell sites out because it's just you're dealing with a milliwatt range versus a radio station could be 100,000 watts. It's huge difference, right?
Yep.
You don't want to live near radio stations. Cell towers ain't a big deal, but radio stations are a problem.
You could avoid it.
That's why they put them in the hills too. There's nobody there except the cows, maybe. But bottom line is that you need line of sight, right? And so it's amazing when you think about it that you could, and then to top it off, the guys in the studio that are playing the records aren't there. They're not in the middle of nowhere on a hill, right? They're sending a signal probably with a microwave link from a studio somewhere to the tower site in the middle of nowhere, and then that tower site's repeating it on the right frequency and sending it out all over that area of the county to cover up to 100 miles or radius, right, or something like that, or diameter. Bottom line is that, and then you run into intermodulation, they call it, where the signal, when it hits like buildings, it bounces off the buildings. So the radio is not only picking up the direct signal from the tower, it's just like in audio, it's picking up the reflections off the building, and it's got to decipher that so you don't hear ghost images of the audio. Right, that are delayed by a few milliseconds. You'd hear almost like an echo in every station you dialed in. So in big cities, that intermod or whatever became a real problem, which again, they had to filter that out in the receivers to be able to deal with that. So what I'm saying is it's a goddamn miracle that FM even worked, right? That it got to you in a reasonable fashion while you're driving in a car, anywhere you put a portable in a home,
Well, and,
GPS is even worse.
well, yeah. But there's also
Yeah,
other
really,
problems.
in a
It's a
city?
satellite at super low power with stuff everywhere, ultra precise.
Yeah, if you ever walk around like when you're in New York
Sometimes
or something like
doesn't
that,
work.
Yeah.
you can. You're near a tall
Well,
building.
tall buildings,
It doesn't know where you are. Remember the one time we called an Uber and they couldn't
you're like
find
10
us?
blocks
Like
off.
2 blocks, 3 blocks off.
It was
Yeah.
brutal.
But there's another problem too, because then everybody probably wants that same area to transmit from, height as might, as you know. And so you got every radio station all in the same area, all fighting each other on
the
different,
same tower a lot of times.
like-
It's brutal.
and they're all like slightly different frequencies, all
Yeah, it's a mess. It's amazing that the shit works at all. So, bottom line is that nowadays everything in our house is kind of a mini RF generator. Everything's
It
got
is,
computers.
to some extent.
Everything's throwing noise out in the air.
Yeah, if you could see it,
You know,
oh my god.
Yeah, right. You're right. You walked in and be like, you're right. If your eyes, in fact, we should make kind of like Jordy from.
That would
yeah.
be cool, yeah.
If you could see the RF spectrum,
Oh my god.
it'd be way worse than a ghost.
Well, you'd have
It'd be crap
AM
everywhere.
radio, FM radio, Wi-Fi.
Yeah, just
every
picture static, confetti, color, broadband noise everywhere, right? And then hot spots all over the place.
Yeah.
Kind of like a thermal image, I guess. It'd be like taking a thermal imaging thing and looking around
It's like
the room.
that. Yeah, it sees you could see something you don't normally. And I think to some extent, you might think initially that it's worse now than ever. But in fact, it's almost better now than ever. Because although there's more noise to have interference issues, Gear's actually made to tolerate it better than ever.
Well, that's
Because it wasn't long ago where everything got interference from cell phones. In the early days of cell phones, everything, always making all these noises.
Especially
from
the
your cell
car
phone.
rate stereo.
Yeah,
yeah.
right, all the time. And now you don't hear that ever.
Yeah.
It's very,
they
very rare.
figured that out.
Yeah.
It's all sorted, right? They have a design down
That took
so
a
that
while.
it's tolerant to these things. Now, the noise didn't go away. It still does. It's still there, right? But it's designed to tolerate it.
Yeah.
And now as we're adding 50 radios to things, we have to tolerate
they
it.
learned how to route the wiring or eliminate wiring in automobiles and put filters in the electronics in automobiles to eliminate it from being a problem. But like you said, it's still there.
It's still there.
The noise is there. So that's what you run into in audio, though. You know, you got such a mixed number of manufacturers, all after different goals. And a lot of them, their main goal isn't to worry about filtering out AM radio interference or cell phone interference. It's not what they do, right? That's the kind of stuff you find out in the field. Once it goes out there and there's hundreds or thousands or millions of pieces out there, unfortunately, that's when you find out what the real world does to this stuff. You know. So anyway, I think we covered that. But to give people an example, unless you have something to add to that, I think we should show people what a radio.
Let's go for the demo.
Yeah, this is a portable FM radio.
Yeah.
Yeah, but what we recommend is something like, well, we can show it on the screen here. I get a little Sony portable AM FM radio.
Yeah, any AM radio really would do it.
AM,
much.
AM or FM, yeah.
Tends to be preferred.
And you know, but yeah, and by all means, you know, have fun with it too. I mean, a little radio like that's kind of cool because it picks up all the local stations.
Oh, you don't have to pay for streaming services?
Yeah. Well, not only that, you know what's going on. Like, you know, if there's a hurricane coming,
local information.
Yes.
Yeah, you don't get that anywhere else, right?
Go around your house with your AM radio.
But this is just a AM FM radio, and we've got it tuned off station, which means right now it's on. It's full up volume. Right? And it's not playing anything. So you don't want to hear anything. You want to put it in the middle of stations because if you have it on station, that's what you're going to hear. Yeah. And so we just want to show you like around this room, like, I don't know, let's see if the mic does anything. See, like, for whatever reason, this mic's radiating noise and this radio's picking it up. So it's probably a combination of things like the cable shielding coming up here. The mic doesn't have a ground. It's floating, right? So it in itself is radiating, right? But look at these TVs. Like, okay. So the flat screens are, and I mean, this isn't exactly made to pick up the noise that's coming off. It's just, it's an artifact of the noise coming off. If you really saw how much noise was coming out, it would blind you. But this is the type of things we're talking about where noise is radiated in the home. And, you know, a suggestion would buy an AM radio off of Amazon.
Yeah, you get them for a few bucks probably.
Yeah, they're probably $10 or under.
Any of them work. The cheaper, the better, probably.
Yeah, whatever.
Maybe.
Yeah, just turn it on, go to somewhere in the middle, and just walk around your house. You'll be amazed. Check out, wave it around your PC.
Well, it'll be everything.
Your screen on your, yeah.
Some things don't matter, and it probably won't pick up a lot. But some things are probably really severe, and especially poorly designed power supplies. That's the biggest offender. There's a lot of, in fact, most power supplies these days are what they call switch mode, which basically means they're electronic, they're very active, and they can be very noisy. Good design ones will put components in, and they'll have very good design, typically, and they'll try to minimize the noise that radiates from outside the box and, you know, outside into the power lines and things like this. But the cheap ones, they cheap out on the things that don't matter because it doesn't really affect the functionality of it. And you may find you have a power supply somewhere that is putting out crazy noise, right? And an AM radio is a shockingly cheap tool to give you a vague idea. It's not, you know, it's no replacement for proper equipment, a spectrum analyzer or something, you know.
Yeah, oscilloscope analyzers.
But the cost of this equipment is just, it's stratospheric.
And you still got to know what you're looking for,
yes.
You know. So that's another topic of discussion, but yeah.
A good start.
Right.
AM radio for $10 or whatever.
But you know what's making noise.
Yeah.
Right.
Yeah. And then, you know, by doing that, you know what to keep away from or separate the good shit from, right? All right, this, I know you wave this radio around the room or wherever, everything that's around there, and you pick out the hot spots. And you say, okay, I'm going to make sure none of my interconnect wiring's near here, or follow it along your power cords going somewhere, you know? And it's a really cool, cheap tool to use, you know? Back in the day when I was dealing with RF, we used to call them sniffers. You'd buy an RF sniffer, and an RF sniffer basically had a diode in it. It was a detector.
Yep.
So, you know, you could hear the noise. It would detect it like a radio. And so you could try to get a call sign or something if you wanted to, and figure out what radio station you were picking up. So you could specifically pick the proper type of ferrite or filter. Because if you just throw a filter at something willy-nilly and you don't know what you're filtering.
You got to know what you're filtering.
You know, you got to know what band you're dealing with in order to really filter it out of a wire. You know, that's a topic of another discussion. But in this case, at least you could find the airborne sources. This tells you what's radiating noise. So you want to keep everything away from it. That's all. You know, and And maybe even throw it on a separate AC circuit or plug it into something else other than where your good stuff's plugged in. Because it's probably radiating down its own power cord too.
Probably.
You know?
And that's why it's not too unreasonable. If you're really going for it, put in a dedicated circuit.
Yeah.
You could, if you do it yourself, if you're experienced and that's legal in your area, you watch some YouTube videos, a few $100s. If you want an electrician to do it, it's really not that expensive usually if you just do a standard 12-2NM Romex dedicated circuit.
Yeah, I mean, in that way, you can keep your sensitive gear on that circuit, and then
it's a little more isolation. Obviously, it's not extreme, but it's a little extra isolation. It gives you that extra length of wire with nothing else.
But it still won't help you from airborne.
No,
because that's vicinity. That's there. Doesn't matter what you plug it into; it's always radiating nearby. So that requires distance. And I always tell people the rule of thumb on that is, and it is a rule of thumb, is that the isolation is the amount of isolation you get between two things is the square of distance. So 1 inch is 1 squared, 2 inches is 4 times isolation, 3 inches is 9 times. So it doesn't take a lot. No. You don't have to put it in another room.
Right.
But a few inches is dramatic versus being next to it.
Yeah, if you get something a foot away, you don't even need to think about it.
Just like this radio. I mean,
Right.
Okay, I'm a foot away now. Now I'm an inch away. That's significant, a foot away. 2 feet away, it's almost not even there. So, you can see how distance really matters.
Well, it's just like magnets, same thing. Everybody knows the closer you get,
it's kind of like
stronger
that.
they get.
It's the same deal. Yeah, distance squared.
A little bit of distance.
So get yourself some distance. I think we covered that as good as we can right now.
Sure. We're no experts, but that's the broad strokes.
Yeah. Hopefully that helps you out. Get yourself a radio.
Yeah.
Walk around the house and see what you pick up.
Like a weird person.
Let us know. Yeah. Let us know what you find. It'd be really cool to find out because we've done this already. Yeah. And sometimes you'd be surprised what's throwing noise out in your room. Be really surprised. Even check out the lamp. Anything that's plugged in.
Oh, yeah. LED balls.
Dimmers in the wall.
Dimmers could be bad.
Oh, they're brutal.
Sure, sometimes.
Yeah. Anything where there's electricity.
Pretty much.
It
might shock you. Yeah. It might be absolutely nothing or it might be absolutely everything.
Be surprised. Thanks, everyone. Thumbs us up. Subscribe. We got more coming. Take care.